So welcome. It's great to see everybody here. It's obviously, judging from the size of the crowd, a topic that's important to a lot of you, so that's good to see. Before we get started, I just want to see a quick show of hands. Is there anybody here who thinks that they are administering a really large Jenkins instance? Okay, I see a few hands. How many jobs are we talking about in the white shirt there? On one instance? Thousands. Anybody got more than thousands? How many back there? 1,500. Anybody else more than that? How about you? How many? 5,000. 55,000. 55,000. Okay, you have the biggest one I've heard so far. You? More? 70,000. Okay. How's that working for you? Not that well. Okay. So I'm going to make a claim here. I'm going to claim that I have administered the world's largest production Jenkins instance with 170,000 jobs on one master. I do not recommend this. But that's one source of the experience that I have to kind of for this topic. And we'll talk about some of the stuff in more detail. But it's good that there's a few people here who have, it sounds like most of you have less than 50,000 jobs. So that's good. That's what we like to hear. You're already on the right track. So that's good. So we're here to basically talk about, basically in the next 45 minutes, we want to talk about best practices, things that you can do to set up your Jenkins master in the beginning to avoid performance issues. There's a lot of things that you can do to give yourself a long runway before you're ever going to run into problems. We'll talk a little bit about JVM tuning practices, which is a big part of how you kind of set yourself up for success. We'll show you some real-world data that we've got from customers of CloudBees and from our experience in support working with people who have performance issues. We can have Q&A after the talk if there's time, and if not, Ryan and I will be in the CloudBees booth down in the exhibit hall. You're welcome to come down and talk to us. We love talking about performance, and that's why we're here. And presumably why most of you are here is that you've either had performance issues with Jenkins before, or you're interested in learning a bit more about the JVM and how to tune it for the best performance you can get out of Jenkins. And you just want your Jenkins users to have a better experience. So that's kind of where we're coming from when we talk about this stuff. CloudBees, as most of you probably know, we're the #1 contributor to the Jenkins project. Kosuke Kawaguchi, who's the founder and the original creator of Jenkins, works with us. And we have the largest group of Jenkins certified engineers working under one roof, including myself and Ryan. My name's Owen Mahegan. I'm a senior developer support engineer at CloudBees. I've been involved with the Jenkins open source project since 2010. I've been involved in documentation, providing support on the IRC channel. I maintain the GitLab plugin. If any of you are using GitLab and the Jenkins GitLab plugin, that's something I've been working on. I've been a Linux sysadmin for 20 years. I have all the scars and therapy bills to prove it. And I currently live in Australia, in Melbourne, but I am American. And Ryan Smith, you can introduce yourself.
Yes, I am Ryan Smith. Some of you met me yesterday and doing the performance talk with Parker Innes, and I am a JVM performance nerd. So this is where I spend most of my time. I lead the stability and performance team inside the support organization for CloudBees, and this is our area of expertise. As soon as we find out that white shirt back here has 50,000 jobs, well, we want to talk to you. Let's jump into it. First of all, good morning. Good morning. Let's try that again. It's the last day of Jenkins World. 1, 2, 3. Good morning.
Good morning.
Thank you.
All right.
I've got two things to show you. One, this tinyurl.com that's up here for JW Performance. These are the slides, so y'all don't have to hold up your cell phones and take pictures. Some of y'all sat through this yesterday, and this is an area that's near and dear to my heart, so I preach it a lot. But if you pay attention to what we're going to talk about today, I'm going to show you real-world data that we have with real customers, where we were able to gain 3,500% performance increases in their Jenkins instances. And these are Fortune 50 companies that have taken what we've learned about JVM and Java administration and tuning, and they've not only used it with their Jenkins instances, they've taken it inside their organizations and spread it out to all of their enterprise Java deployments. Next slide. I'm on the phone 3 or 4 times a day with my clients, and the number one thing that I've found that comes out of my mouth is Jenkins is a Java application at the end of the day. With any kind of Java application, you're going to be talking about enterprise Java deployment. And that's what we're going to discuss today. Some of the takeaways that I hope y'all get from this is, number one, Jenkins is a Java application. I can't stress that enough. Number two, we're going to start to talk about taking a scientific approach to performance and stability. We are going to have you leave here with some of the tools that we use on a day-to-day basis from the support organization to diagnose issues that we see on the regular. And I'm going to show you that data where we'll show you 3,500% performance increases. Next slide. So with any Java application, you're going to have a Java virtual machine. How many of you are familiar with administrating a Java application as a JVM administrator? So I see about 5 hands go up. So when you go to install Jenkins, I think there is this misconception that it's a set it and forget it situation. And as we onboard more jobs into Jenkins, you set your heap size, you set a memory size, you set a resources for whatever that we're doing. We tend to not go back and add more resources or give it any love further down the road. And I think this is where 95% of the issues come in down the road when you're onboarding new teams or onboarding new jobs. And at the end of the day, Jenkins is a job application. It needs love. Next slide. Basic JVM architecture. Classes are basically loaded into JVM memory. You've got a compiler and a garbage collector that exists inside of the JVM. But most importantly, what we're going to talk about today is the garbage collection. It's one of the most overlooked aspects of the JVM. Next slide. With Java 8, which is what we're talking about today, and I know that there's been news that we are moving to Java 11. It's coming. The current garbage collection algorithm that we recommend is the G1 algorithm. There are several algorithms that come with JDK8. What we found in our baseline testing and performance testing is that the G1 algorithm outperforms any other algorithm that's available with JDK8. This is one of my favorite slides, and I show this to clients all the time because a lot of people think that when you set heap size, that's it. That's your resource that you're giving the JVM, and that's really not true. Heap size is just one aspect of it. You've also got, with JDK8, the concept of metaspace. And this changed from Java 7, where if you're familiar with permanent generation space, it's now called metaspace. And metaspace can grow unbounded. And metaspace is where garbage collection takes place. This is where thread stacks happen. This is where socket buffers and JNI programs allocate memory in this area. I think this is my favorite slide out of the deck because the JVM is just one piece of this operating system memory, and the heap is only one part of the process memory. And you've got this young generation, old generation, and metaspace concept underneath that. Next slide. As with any enterprise Java application, it requires JVM administration. So it's not just about defining heap sizes, it's about figuring out how much heap to give your application. So we're going to talk about how you can get to those numbers by examining garbage collection logs, thread dumps, and heap analysis. One of the number one things I tell people is you're not going to be able to figure out how much heap your application requires unless you're enabling garbage collection logging. So right off the bat, if you don't have these basic garbage collection logging flags enabled, you're doing yourself a disservice. And we're going to give you all the links to what I call the magic arguments. Traditionally, with enterprise Java deployment, there was this concept that a Java application needs 3 things, and that's memory, CPU, and I/O. And what I would call that are macro metrics. It doesn't allow you to forecast issues or be able to think about how much heap space or resources that your application needs. So I think there's this new concept, new way of thinking that we're calling micrometrics. And with micrometrics, that's garbage collection logging, thread dump analysis, and heap analysis. And by looking at those micrometrics, you're going to be able to tell object creation rate, You're going to be able to tell how much heap is currently in use, what your young generation, old generation heap size and metaspace size is, and that way you can forecast better the needs of the application at a resource level. Next slide. So again, macrometrics, this is where we're looking at response time of the application, CPU utilization, memory, that's traditional. Next slide. And micro, you're looking at object creation rate, garbage collection throughput, how much memory am I wasting, how many open file descriptors are there, what my garbage collection latency is. And Jenkins is a low latency application. This is not something that I want to have a garbage collection cycle last more than a second. So in our support organization, we aim for 99% application throughput and under a second of garbage collection time max intervals. Next slide. So the last piece that I think we forget about as we're going to install Jenkins is that this requires system administration as well. And that's because log rotations have to happen. Once you start enabling garbage collection logging at the JVM level, it's not going to clean up itself. And so you have to use additional tools like log rotate. Monitoring systems need to be in place so that you can look at CPU utilization, heap utilization, and that just doesn't come out of the box with JVM. So, we use tools like top and top-h to show us what's going on at the CPU level, but there's whatever monitoring tool you want to use is fine.
Right, so we'll talk about here a little bit about just Jenkins performance and what it's like to administer a Jenkins server. I feel like this is what it's like. You start out using Jenkins, everybody's having a great time. You start small and you're doing a small number of builds. You don't have too many users, and you think this is amazing. I'm deploying automatically, I'm building automatically, testing, everything's going great. And maybe you're sort of one team within a bigger organization, and other people start kind of getting involved and saying, oh, we want to use Jenkins too. And so they add their jobs. Your jobs start to get a little bit more complex. You start integrating with more external services. You've got more and more users. And it's still, you think everything is more or less fine, but under the covers, things are starting to go wrong, and it just kind of ends badly. And so this has kind of been our experience a lot. Most of our customers start out as Jenkins users, and everything's going great, and it's growth that they're not kind of aware of, integrations with external services that they're not aware of, changes to job complexity, especially with the use of pipeline, that sneak up on you, and suddenly you're having an outage, or you're having, all your users are saying Jenkins is really slow, and you kind of don't, it comes out of nowhere. Our experience is, some of the reasons why this is difficult and why it presents a bit of a challenge is Java performance tuning skills are not really universal. If you don't work at a company that's a Java shop and you don't have any people who are experienced with deploying Java applications in production, it's like Brian said, you'll tend to think of Jenkins as a set and forget sort of tool, and it comes back on you later. And so teaching these basic Java administration skills to people has been one of the ways that we've seen people kind of benefit a lot and learn how to just learn about care and feeding of Jenkins. Usage of it kind of grows organically, so you get more and more users and more integrations, and that introduces load. It comes from a lot of directions, so people often say to me, what's the most number of jobs I can have? And it's like, well, how complex are the jobs? How often are they run? How much build history are you retaining? There's a lot of factors. So there's not kind of a single metric that you can really use. And the architecture of Jenkins is a little bit quirky and sometimes surprises people. Some of the big ones, or the big things that catch people by surprise, are that there's no database behind it. So it does a lot of file I/O, and that performance at the file system level is also really important to making sure that things are going to work well. So performance issues that we commonly see in support, poor disk performance is definitely one, particularly with network-based file systems. Unoptimized memory and GC settings, we'll talk a lot about that. Abuse of the REST API, you'll get people who will try to build a dashboard of their own out of the data that's in Jenkins, and responses to REST API requests aren't cached. And so if it gets hammered, you can introduce a lot of slowness that people don't really realize where it's coming from. And then there can be non-performant plugins, and we find that occasionally as well, where a plugin that's just not really written that well works fine at small scale, but at really large scales it introduces other kinds of issues. So just some initial setup best practices. The things that we talk about here are kind of basic, but if you can adopt some of these things, you give yourself a lot more runway before you're likely to run into issues. So these are the things that people come to us with a performance problem and we say, oh, you just need to do this and you'll be fine. And so rotating build history so that you're not keeping an infinite amount of build run history is really important because that takes up more memory. The more of that you have takes up memory, and plugins that try to graph or otherwise report on the history of a job will get progressively slower the more of that you have. So don't keep more than 30, 60, 90 days of it unless you have some compliance need for it or whatever. And even in that case, it's ideally try to find another place to warehouse that data if you have to for compliance reasons. We recommend that you run Jenkins under a JDK install of Java and not a JRE. It just makes it a little easier to debug if there are issues later. We don't have to say, oh, you need to restart it in a JDK before we can do some deeper debugging. So just run it that way from the start, and that's helpful to us and to anyone who's helping. Yeah, sorry. Sure. Right. Well, so the build history rotation is configured per job. Yeah, do you want to speak to this a little bit? About the defaults?
Yeah, were you talking about containers?
Well, just what defaults do we ship with?
Out of the box for CJ, well, I don't want to use CJP. Out of the box for CloudBees Core, we're currently shipping with some different settings, and I can actually pull you aside afterwards and have that conversation with you. It's a good 30-minute conversation.
Yeah, so we also suggest that you use SSD storage, particularly if you're using network-attached storage of some kind. Make sure that there's SSD underneath it and not spinning disk, because the performance benefits are pretty major. And this is not as controversial as it was a few years ago when SSD was more expensive. But I have a customer right now who's having some network storage performance issues, and it seems to be partly motivated by their use of still using spinning disk on their NFS mounts. We always say use either NFS 3.0 or use 4.1. At this point, there's really not any reason not to use 4.1. It's pretty much supported everywhere, and any modern kind of NFS appliance is going to support it. But NFS 4.0 has really poor performance under fast or frequent write loads or frequent small write loads, and that's a lot of what Jenkins does. So we see performance benefits from people switching from 4.0 to 4.1 quite commonly. Use the G1 garbage collector, enable GC logging. We'll talk about that in more detail in a bit. Set the heap size explicitly. We always say to start with at least 4 gigs and set the minimum and maximum the same so that you don't have to waste time allocating more memory from the system later when you need it, and you don't have to worry that potentially another process on the system has taken up memory so that Java can't allocate more. Monitoring, like we said, monitor CPU and I/O performance. You'd be surprised how many people don't have application level monitoring of a Java application that they're using in production. But it really helps when you have issues that only occur at certain times. We want to see when those are occurring and try to correlate that with activity on the system, whether it's people running builds or whatever. There's a plugin called Support Core, which is available for open source Jenkins as well as within CloudBees versions of Jenkins, it's included. But you want to have this installed because what it gives you is the ability to create what we call a support bundle, which is a zip file that contains all the information about versions of Jenkins, versions of Java, versions of plugins, logs. If there's GC logs, those are included, all that other type of stuff. So if you're a CloudBees customer, when you come to us with a performance issue, the first thing we'll ask for is a support bundle. But if you're using open source and you're getting support from folks in the community, if you can provide them with a support bundle, whether you're having performance issues or a bug or other things like that, most of the data that would be needed to diagnose those issues would be in a support bundle. And so if you create a JIRA in the open source Jenkins JIRA tracker and you include a support bundle, you're much more likely to get attention on that and things like that. This link here is to our recommended JVM arguments to use with Jenkins. So if you go there, it's a whole document that we provide. We provide it to CloudBees customers as our kind of recommended minimum practices in order to what we call prepare Jenkins for support. but included in that is a list of our recommended arguments for GC logging using G1 garbage collector and tuning the collector a little bit specifically for Jenkins use. Yeah, sorry. We're talking mostly about master. That's really where we tend to see performance issues. It's not too common to have issues with the performance of the agents because the agent process itself is not doing that much. So the master is sending sending commands to that, but that's then executing builds in their own processes and things like that. And the agent's really just responsible for then streaming the output back to the master. So it's relatively uncommon that we see issues there unless the agent that the process is running on is memory constrained or something like that. Would you agree?
Yeah, let me say a couple things on that. As a more general retort, I would say that the agent is just another Java application that's running in a JVM. So as the Java administrator, or the as the JVM administrator, you should know how much heap that your JVM needs, right? I would also direct that to, who raised their hand about containers? I thought about that for a minute, what you said, and we make recommendations based on baselines, right? So all the recommendations that we're talking about up here are done through baseline testing, what we see out in the field, these monolithic masters that have 100,000 jobs, and I make these recommendations, especially around the JVM arguments, based on what we've seen work. I'm not preaching these are the end-all, be-all arguments. And I would encourage you to do your own testing and baseline it, make a change, take the scientific approach, and then re-baseline it. Did you gain some performance in doing that? On the container piece, the same deal. To answer your question point blank, we do not ship our images for CloudBees Core with those settings. We're making an assumption that you as the JVM administrator are going to change those settings either based on our recommendations or really based on the size of the heap that you're setting for the JVM. So out of the box with Java, the parallel garbage collector is set unless you define otherwise. And what I would contend there, especially with our engineers, is we ship with a default of a 1 gig heap. And I think that's probably where your question's coming from. Okay, so with a 1 gig heap, the parallel garbage collector is more performant than the G1. But I wouldn't deploy a 1 gig heap in production, right? So I think I'm making that assumption that you're going to go to 4 gigs of a minimum heap size, therefore you need the G1 garbage collector with that. Hopefully that answered your question.
Sure.
So for basic monitoring like CPU kind of stuff, we use Mango.
Yep.
But for other metrics, right now we're using Melody.
Mm-hmm.
But do you have any recommendation on like what to use?
I'd say nothing specific. It's just the fact that you're monitoring and that you have graphs and possibly alerting based on that is really useful. So it's whatever works well in your environment and what your team is familiar with is more important, I think, to me than any particular tool that's going to be better or worse than something else. So as long as you're monitoring mainly the memory usage and performance of Jenkins itself, that's what's really important to us, I think. So just talking a little bit about initial diagnosis of issues, this is kind of what we tend to do in support when someone comes to us with a ticket and says, we're seeing performance issues. First thing I often say, sometimes people will say, oh, we're seeing the CPU usage is really high. And that's often a distraction from what the real issue is. So if Jenkins is under really high load, it tends to slow down basically due to either memory issues or just request volume being too high. But if memory is low and Jenkins is spending a ton of time, or the JVM is spending a ton of time in garbage collection, or storage is unusually slow, and that's causing jobs and requests in Jenkins to back up, and Jenkins starts creating more and more threads, those things will drive CPU levels higher. And if you look at that as the first metric and you think, oh, the CPU usage is really high, it's often not really what's going on. Jenkins is not ordinarily that CPU bound. It's much more memory and I/O bound. So if you see high CPU usage, you should be looking for other things as well and checking those other metrics. So we tell people, and what I do is first right off the bat, look at what heap size the customer is set and what heap size is in use. What's their maximum size? What's their size in use? And what is that relative to the available memory on the system? So we can see if they're running close to the system memory limit or close to their heap size limit, and that suggests to me that there might be a garbage collection issue that I want to look at next. Just check storage performance, particularly if you're using network storage, and make sure that it's available so it hasn't disappeared or gone off the network, whatever, and that the performance is reasonably good. So it's another thing that you want to be monitoring with a baseline level so that you understand the normal performance under good conditions is this, and right now I'm seeing that performance of storage be much worse, and so what's going on there. I always look at the dmessage log on Linux-based masters, which is most of our customers, because it often illuminates things like storage issues, disk problems, network issues, all kinds of things like that can be clear as day in the dmessage log. The main Jenkins service log is also useful to look at, just to see if there's a plugin that's dumping lots of stack traces or something like that. If there's an external integration, like with GitHub or with, say, LDAP or something, which has gone unavailable or is slow, you can see errors reflective of that in the service log, and it will kind of direct you towards further debugging. And then there's something called the slow request logs, which a lot of people don't know about, but if you look inside the Jenkins home directory, there's a subdirectory called slow-requests. And it contains a log of every web request to Jenkins, including API requests, that take more than a few seconds to run. And it logs where the request came from, what the request was for, and it shows the stack trace of what was going on in the JVM and what Jenkins was essentially trying to do to satisfy that request. So this is an example of an entry that I discovered in a customer's environment right before, as I was preparing for this talk. So this customer came to me and said, every time we log into Jenkins, it's incredibly slow, and I can't figure out why. And they thought it was an authentication issue. And what I discovered was the request to actually load the Jenkins homepage, so it's doing a get slash, was taking 87 seconds, which is insane. And I was wondering what is going on here. So we found this in the slow request logs, and we see that it's trying to load this thing called uptime column. And I thought, what is the uptime column? So I looked down in the stack trace, and I see there's a plugin called Uptime, which I wasn't familiar with. So I searched for it. This is a plugin that was released 6 years ago. It's only had one release ever. It has a very small number of installs, and it adds an uptime column to the list view, which shows the percentage of time in the history of a job's life that it has been successful since it was first built. And I thought, okay, if these people are not saving any build history, then I'm going to be very angry. Or not rotating any build history, I'm going to be really angry. And so sure enough, they had several years worth of build history. And so just this one plugin was causing them all this pain. And they totally had attributed the issue to something to do with their authentication system and so forth. So fortunately, pretty easy to identify. And I just said, let's just not use this plugin. It's not really getting you any really useful or interesting data. And it's obviously causing a lot of problems. So after this, once we've kind of done those basic analyses, and if none of that has yielded anything, then we start looking at GC logs and thread dumps. So we use these tools called GC Easy and FastThread. These are free online tools that have kind of a basic free version. There are other tools you can use. There's ones you can run locally, things like that. But these are really handy for us in support to just quickly dump some logs and look at, see some output. And we'll kind of show you what it looks like. And the things that you get from a report from a tool like this can kind of highlight something to you that you might otherwise miss. When I was administering that master with 170,000 jobs, I used to manually grep through thread dumps trying to figure out what was going on when we were having performance issues. So FastThread makes this much easier. You can run the paid version of these tools on premise if you want, which is what we do at CloudBees, so that we're not shipping customer data to the cloud or anything. But the free versions are pretty effective. And so I think Ryan can talk about some of this in a bit more detail.
Yeah, who here has actually done a Threaddump analysis?
Okay, cool, a few people.
That's
10, 15
awesome.
people.
That's
Yeah,
a lot
great.
more hands than yesterday. So I think by doing Threaddump analysis and GC analysis, this falls into that micrometrics category again. And these tools are incredibly powerful. It's way different from the days of yore where we had to go do decimal to hexadecimal conversion and look up threads. It was a mess. So literally uploading your logs to tools like this will give you an immediate analysis. So I would encourage everybody to check it out. Who here understands the inner workings of garbage collection? see
some
6 or 7
We've got a
people
couple of
there.
maybe.
So yeah, garbage collection is voodoo science. And I said this yesterday to some of you that were in the room. There's literally a book that was written in like 1987, and I think somebody came up and said, I actually have that book, and dated themselves. But basically, it's the component of the JVM that is taking care of objects that are no longer referenced. And this is another one of my favorite slides, because I think this speaks to, if you've never looked into garbage collection, this is the easiest way to understand it. It basically shows you that objects are loaded into memory in that top green graph. After they're no longer used, the garbage collector goes and marks them and basically puts a flag on them, right? Once they're marked, it goes through this sweep cycle and removes it out of object memory. Then it compacts it back down. And if you go to this next slide, if we were to flip that, you would know exactly that it's doing this sawtooth pattern. And that's exactly what we're looking for. That's a healthy garbage collection cycle. So anytime that you're doing a garbage collection analysis, this is what you want to see. Next slide. What we don't want to see are cycles that look like this. And those red triangles that are taking place there, those are full garbage collection events. So you'll note that at the very end, we have this memory leak pattern where the garbage collector is invoked so many times that it's trying to just clean up memory over and over and over, and it can't get enough memory back. And so we end up getting killed, either at the Linux level or within Java, depending on
The application is
where the
effectively unavailable at that point.
Yeah, so when we're in that far right-hand side, all those threads are being taken by garbage collection events. And GC threads take precedent over everything else, and they're stop-the-world events. So HTTP calls aren't going to go through. People logging into Jenkins aren't going to be able to log in. And typically, you're going to 404. That's an awesome question. We haven't talked about it yet, but there's young generation and there's old generation objects. And when an object gets loaded into memory, it goes into young generation. And then there's a cycle of time that takes place, and depending on how long it stays, it'll get moved to old generation memory. And then if it's still referenced, it will eventually get cleaned up later on down the road, but that's the difference between young and old.
So young objects are the most likely to, young objects are short-lived, or most objects in Java are short-lived. So when something's in the young space, it's most likely to only live for a little time and then need to be collected. So it makes the garbage collection process faster by separating from young and old. You can collect young things first and then move to old if something is still referenced after that.
So with Java 11, there's some really exciting stuff coming out. And Shenandoah is one, and ZGC is the other. So for all intents and purposes of our talk and today, we're not getting off of JDK 8 anytime soon, right? And G1 is going to be where we're headed for the next foreseeable future. However, for those of you that are experimental and are really interested in this stuff, I highly encourage you to go check out ZGC. It's boasting almost double the speed of the current G1 garbage collection algorithm. So with that said, if these are things that I'm looking at that speed up my Java performance, and ZGC is coming in and saying I can give you 200% of that, I would be really interested to go check this stuff out. So I would encourage you to check out the slide. There are links in here to some talks that Alexei Shipolev talks about. He's from Red Hat. He's talking about ZGC, some really neat stuff. Next slide. This is what the Threaddump Analyzer looks like. Well, when you take a thread dump, we typically use tools like JCMD or JStack, and this is also why we emphasize that it's really important to have a JDK over a JRE so that you can get the development tools that come with the development toolkit. Once you take a JStack thread dump, it's basically just text file, you upload it here, done and done, it gives you a thread analysis. And this is what a thread dump analysis looks like. As soon as you're using a tool like FastThread, it'll tell you right there, I've got 530 threads currently taken at the time of the thread dump. 95 of those threads are blocked. A lot of our folks that reach out to CloudBees support, or like, okay, well, I've got 95 blocked threads. What's going on there? While this is something to take a look at, threads are blocked all the time. It's not necessarily a bad thing. It can be bad when multiple threads get blocked, and then we have a deadlock situation, and we've got bottlenecks that eventually have higher thread counts. But
Or when they're blocked for a longer period of time.
yeah, absolutely. During the time of a thread dump, you will typically see blocked threads, depending on what's taking place in the application, for what it's worth.
So we often recommend, we get our customers to capture a series of thread dumps over a period of a couple of minutes so we can see what the thread state is over a period of time, and that helps us kind of zero in on an issue.
Yeah, so when you're using a tool like JStack, it's recommended that you take a thread dump, like Owen said, every 5 seconds over the course of, say, 2 minutes. And that will give you a good baseline, because at the time of your taking of your first thread dump, it may differ from the time at the end of the 2-minute execution, and you might see completely different output.
Sorry, go ahead.
So by taking a series of thread dumps, does this tool analyze the series or just one dump at a time?
You can upload up to 5 at one time, and then it'll show you the difference between each of them, and it'll give you a summary of the overarching one. So I worked on one recently where I had someone take thread dumps for every minute for 20 minutes, and I just analyzed, let's say, like every couple minutes worth of them to get a better view of what was really going on. It was analyzing a slow startup performance issue.
Yeah, for what it's worth, the enterprise version, you can take hundreds of them
Right.
and upload it.
Yep.
Does it immediately.
So this is
Thanks
an
for that.
example from a Threaddump analysis that I did a while back, where someone was, again, reporting slowness on the main Jenkins page and just general UI slowness. So we captured some thread dumps and looked, and when we dug into the blocked threads, we see a lot of threads blocked waiting to collect or waiting to load the weather column. So if you're familiar with Jenkins, the weather column is the little column that shows the thunderstorm or the sun or whatever. That's similar to that uptime plugin. It needs to look at the full history of each job in order to calculate the weather icon. And if you keep a huge amount of build history or you have a huge amount of jobs, then just the rendering of that icon can be very slow. So if you have an unusually large master with an unusually large amount of build history, sometimes this can be an impediment, and we can suggest how to disable the weather column. But the point here really is not about the weather column, but just that it's something that when we look at this, it's clear pretty immediately to us that the problem is there, or the problem is with a certain plugin or something like that. So the point is that thread dump can illuminate the cause of a problem sometimes really easily. Other times it shows all kinds of different things, and we have to dig a little bit further before we identify something. But it's a great way to debug and potentially isolate a cause rapidly.
Some of you saw this slide yesterday, so this will be a little duplicative. How many of you have heard that Jenkins is slow from your developers? That's a lot of hands.
Half.
This is the number one thing that we see on the support team, and it's our number one. We did a talk yesterday, the top 5 issues from Jenkins that we got, and we polled thousands of support cases that we get a year, and this seems to be the number one complaint. It's also it's also the top thing that we can fix. The top reason that I see for Jenkins instances being slow are due to misconfiguration of garbage collection or JVM parameters. And the links that I have in this slide that I really encourage y'all to download have links to some of these administration best practices that we've put together. That top link actually walks you through. Somebody asked me yesterday, how do I do a thread dump analysis manually? And that top link will walk you through how to do a thread dump analysis from start to finish. It also will walk you through how to do garbage collection analysis, top to finish. The second one is the JVM troubleshooting link. This is a guide that we put together where if you are having issues, you can link to this. It'll basically walk you through some of the steps that we take from a support team to diagnose these issues.
Sorry.
Go back.
Sorry.
Some of the other causes that we see for slow Jenkins instances are pipelines that are poorly developed. They're monolithic in size. They're polling the world. They are doing some kind of infinite loop. We also see very poor directory services configuration. And this is really typical. But most of all, we see bad JVM arguments. Again, there's no database like Owen was saying, so file system I/O performance is key. At the end of the day, though, all of these things are fixable. Let's go to our next slide. So some of you saw this data yesterday, and I apologize for it being duplicative, but
Right.
It's, I think, my favorite thing to hang our hat on, to say, this is real, listen to what we're telling you for the JVM arguments, because this is a 3,500% increase that we can get you, or that we have done. So if you look at this data, this is a garbage collection analysis that we did for a Fortune 50 bank. And you can see that the KPIs that I'm looking up here, there's throughput and latency. These are two things that fall into the micrometrics category that I was talking about earlier. So application throughput is essentially 92% right now. And what that means is that 8% of the time, the application is spent in garbage collection cycles. So if you look at the number of garbage collection cycles below that, it's almost 42,000 garbage collection cycles over a 72-hour period. And I see that the max garbage collection pause time is over 20 seconds. That means that when there's a garbage collection event at the 20-second mark, the application is unresponsive. Nobody's going to be able to log in. You're not going to get any HTTP requests. You're not going to get any GitHub polling, nothing. It's stuck doing a garbage collection cycle. So ideally, like I said earlier, we want to see those numbers at 99% throughput and under a second for max pause GC time. Next slide. So when we went and did the analysis here, you can see that these JVM arguments were in play. And I can tell you from experience in reading the Oracle documentation, which is written by lawyers, these arguments all have overhead. In fact, all JVM arguments have overhead. And I would encourage you to, before you take my advice and put some of these arguments in, go read, figure out what they do. Most people historically read blogs, come to presentations, listen to this, and will go put these arguments in without fully understanding what they are doing. And this is kind of what led us here today. Full disclosure, I recommended those arguments a year ago. And because of that, we were seeing this slowdown and poor garbage collection cycle tuning. So removing these arguments is what saved us here. Now, you'd ask, why would you recommend that a year ago? The JDK a year ago was in a much different place than it is today. And so with every release of the JDK, there's bug fixes, there's memory leak fixes, there's updates to the garbage collection algorithms. I mean, there's so much that goes into it. So the old way of thinking was fine tune it. Let's try to work our way around the known issues, the memory leaks, the bugs. And by doing that, we had to fine tune the garbage collector. The problem with doing that is I'm not smarter than the garbage collection algorithm. And by putting arguments in there like this, I'm trying to be. So I'm essentially throwing a wrench into the cog of the algorithm instead of allowing it to do what it's intended to do. So what we went and did is remove all these arguments, updated the JDK to the latest version, and keep it simple, stupid, right? Look at that throughput jump to 99.5% from 92%. And look at the number of garbage collection cycles go from 42,000 down to 2,800 over a 72-hour period. The max pause time is still, you'll see, one 3-second instance. And I'll take that.
Yeah.
I'll take that because over a 72-hour period, I had one garbage collection cycle that took 3 seconds, whereas before I was having 20-second garbage collection cycle times and almost 42,000 of them. Next slide. One other great thing that we can hang our hat on from working with a big shipping company. I don't know if anybody's in the room from big shipping company. Working with these folks over the last year, what was reported was their high availability was constantly failing over. This was happening on a daily, if not every other day basis. And first you start looking at high availability and the configuration and what we're doing. Well, high availability is set in this instance to fail over after 10 seconds of unresponsiveness. That's aggressive, I'll admit, but it should be possible. If we look at max garbage collection cycle duration time here, you're at the 20, 22, 23 second mark. So each one of those garbage collection cycles, remember, is stopping the world. Nothing else is going to go through, including the pings and pongs that are happening at the HA level. So this was causing HA failover. Next slide. So if we went and looked at the JVM arguments, again, I see 2 arguments that we recommended. And by removing that and also looking at what the causes of the garbage collection cycles are, and by the way, these are all coming out of GC Easy for what it's worth. So this is something I just popped in. It shows me all this. Notice that that system.gc method call is being called there. And then I've got a total time of 11 minutes where garbage collection cycles are being invoked. System.gc is interesting. It's essentially an API call that you can make to the garbage collector that says, I want you to stop what you're doing and do garbage collection cycle because I told you to. Again, that sounds like you're trying to be smarter than the garbage collection algorithm. Why not let it do its thing? So I went and looked in the Jenkins code. There is no system GC calls that we make. This is all third-party plugins and developers trying to be smarter than the garbage collection cycle. So by disabling explicit GC, which is something that we can add as a JVM argument, I'm saying that anytime that's called, ignore it. Just don't do it. Next slide. That throughput goes to 99.8%, and my latency went down to 660 milliseconds. That's a 3,500% increase in performance by just tuning JVM arguments and garbage collection. So if I sound passionate about this stuff, it's because it actually works. Next slide.
Right, so we're running a little short on time. We'll just kind of wrap it up here. But we'll talk briefly just about how to scale out when you are kind of reaching the limits of a single master. So even when you've applied some of the performance tuning recommendations that we have, you'll only get so far. So if you have a lot of jobs, if the system is very busy, you're doing tons of builds and things like that, eventually you'll outgrow one master and you're going to need more. And so people often ask us, when should we scale out? And we kind of say, well, it depends. Like I said earlier, how many builds, how often are they run, how complex are they, that sort of thing. Jenkins is memory bound and IO bound, so make sure that you monitor those things. Avoid huge masters with 55,000 jobs or 170,000 jobs. Segment them logically if you need to, so create a master for each team or each business unit, something like that, where there doesn't need to be interaction between the jobs that are on different masters. It's a simple way to kind of spread your workload around. And we generally advise, as a rule of thumb, not setting more than 16 gig of heap. So if you find your Jenkins instance is needing 20, 24, or more gigs of heap memory, it should be a clue to you that you should be starting to scale. If you're an open source Jenkins user, scaling horizontally is a little bit DIY, so you'll need to spin up another master, migrate your configuration over, validate that, migrate jobs over, validate those. If you use configuration as code, you can create duplicate masters with identical configurations a lot more easily than you used to be able to, so that should help. If you're a CloudBees customer, it's a little bit more magical. We have something called CloudBees Jenkins Operations Center, which can control multiple masters and sort of set policy across multiple systems. And it also lets you spin up new masters just like one click. You can centralize authentication on the CJOC level, so all the masters use the same auth. And you can move jobs from one master to another with a process that will make sure that the next master has all the required plugins at the right versions so that that job will continue to work successfully. And you can also trigger jobs across masters if you do have some kind of, you need to have a relationship between two jobs that are on two different masters. This is kind of our last slide. We have some resources available. Go.cloudbees.com is where you can find our knowledge base, which is all generated content from folks like Ryan and myself in the support team. GC Easy, Fast Thread, we talked about those. Jenkins JVM Arguments, those are our specific recommendations that you should start with as a source of tuning. How to capture and analyze, or mainly how to capture a thread dump from Jenkins. And then we have this blog post that's basically Enterprise JVM Administration and Jenkins Performance. This is your recent post that you wrote, right? Yeah, so this is Ryan's very passionate kind of talk about this in a lot more detail. That's about it. Ryan and I will be in the CloudBees booth basically now, as soon as we can get there. So if anybody has more questions, you want to talk about performance, you're having specific issues, feel free to come down. We love to talk about this stuff. We'd be happy to hear from you. And that's it. Thanks for your attention.
Two things.
Sorry.
Hey, one last thing before everybody goes. If you don't mind, there is a survey on this presentation that is available through the mobile application. So if y'all could do us the favor of taking that, we'd really appreciate your feedback. Thank you.